Welcome back. My name is Rob Cornick and I'll be your instructor for this lesson. Today's ROV pilots are both challenged and rewarded by increasing technological capabilities. On the one hand, technological advances lead to more sensors and more tooling, but this increases the demands on their time and attention. On the other hand, autonomous capabilities are taking on more and more of the piloting tasks, allowing operators to focus on the mission at hand and not worry as much about how to get the vehicle exactly where it needs to be. So, for anyone who feels like they need an extra hand, the VideoRay Defender and Greensea's workspace control software have the solution: dynamic positioning. While dynamic positioning has been around for over 50 years, smaller sensors have only recently enabled it to be employed on small portable ROVs like the Defender. This lesson will introduce you to dynamic positioning and the tools that leverage this capability and reduce the workload and the skills required, all while doing a better job than most humans can. Additional information about the Defender, Greensea's and enabling sensors can be found at the link at the bottom of the narration text below. Dynamic positioning is a system that synthesizes sensor information into a navigation solution, and once the vehicle knows where it is, it can be controlled to stay there, even if forces are working against it, such as currents, too much buoyancy, carrying heavy loads, or operating at unstable orientations, like extreme pitch angles. Having the vehicle remain in place is known as station keeping. And, when the vehicle knows where it is and how to stay there, it can also be commanded to go to a new location with great accuracy and precision. This is known as autonomous navigation. The Defender uses a Doppler velocity log, known as a DVL, which is an acoustic tracking device with 4 downward-looking transducers, each angled slightly outward. The DVL uses the Doppler effect of the beams returning from the bottom to measure the velocity, speed and direction of the vehicle. Knowing the velocity of the vehicle and the time of travel, the distance travelled over the ground can be calculated and the new location of the vehicle determined. In the case of station keeping, the DVL returns indicate to the software that the vehicle is moving away from the selected point. So it applies thrust in the opposite direction to the force that is trying to move it, and so returns the vehicle to the chosen station. In the case of autonomous navigation, the vehicle applies thrust to move itself in the direction of the destination. While moving, it constantly updates its current location and makes thruster adjustments as necessary until it achieves the selected position. On arrival, it commences station keeping. To maintain auto control, the DVL must have a bottom lock. Without a lock, there will be an auto is unavailable alarm, and a no lock message will be displayed at the bottom of the depth instrument, and you will not be able to engage dynamic positioning. Note: the DVL's range is between 30 cm to 75 meters, or 1 foot to 250 feet of altitude from the bottom. Outside of this range, the vehicle will not have bottom lock, and dynamic positioning will be unavailable. There are solutions available to extend the useful range, and these will be discussed in future lessons. DP is engaged and disengaged using the dynamic positioning button on the control bar. When active, the button will be green. Once engaged, the vehicle will be in station keeping mode. When dynamic positioning is enabled, a station is created at the location of the vehicle, and the system will try to keep the vehicle at the location of that station. The green X indicates this is the active station. The vehicle will try to move to or remain at the active station. Don't worry, like in other auto modes, you're still in control. Operators can override the dynamic positioning at any time. Simply move the desired input as if the vehicle is in manual control. Note that your inputs are moving the station and the software determines the amount of thrust required to keep up. This is similar to moving the set point in the auto modes. Dynamic positioning and the auto modes are independent. With only dynamic positioning on and the auto modes off, the heading will not be maintained and the depth or altitude will not be maintained. Generally, dynamic positioning and auto modes will be on to provide full autonomous control of all vehicle dynamics. There are several modes of operation that are enabled once the vehicle is in dynamic positioning. The first mode is jog controls, or the ability to move the vehicle in small increments. Like the auto modes, you are no longer controlling the thrusters with manual proportional inputs. You are commanding the vehicle to move a specific amount in a specific direction. The software decides how much thrust is needed and in which direction. For example, if you're conducting a pier wall inspection and there is wave action, the thrusters will need to constantly switch from one direction to the other to counteract the surge. The other two modes are mentioned here, but they are beyond the scope of this lesson and will be addressed in future lessons. The first of these is waypoints, which are set locations which can include depth. The vehicle can be commanded to go to these waypoints. The second is missions. Basically, a mission is a sequence of waypoints that form a route. Mission controls are capabilities to stop at a waypoint and reverse course amongst other options. We will discuss waypoints and missions in more detail later. The jog controls window can be opened from the control bar. The jog controls window includes the jog controls and some mission controls. For now, we'll only focus on the jog controls. Before using the jog controls, you should set or verify the jog amounts. 3 input fields are provided in the lower left of the jog controls window. The XY jog controls the distance to move in the forward, reverse, and lateral left and lateral right directions. The turn jog is the amount of yaw in degrees for each jog. The Z jog is how much to increase or decrease the depth with each jog. Note, the units of measure are consistent with the current setting. The units can be set in the Map Config tab. The jog button initiates a jog. The button functions are shown in this image. Remember, the distance or angle increment for each jog is set in the jog increment inputs. It is recommended that the jog increment remain small. It is easy to click multiple times to move a further distance. Also, if you need to travel a greater distance, as you have seen, you can take over manually and get the vehicle in close proximity before you revert to using the jog controls again. Setting the jog increment to a large value can cause unexpected excursions and the possibility of a collision if you're not careful. An emergency stop feature is available. If you need to stop the vehicle while it's under jog control motion, tap or displace the joystick. This will move the station to where the vehicle is currently, resulting in station keeping at this location. This can be helpful if the jog control amount is accidentally set too high or when working in low visibility. In addition to the on-screen jog controls, you can use the keyboard arrow keys to initiate jogs. The pattern is fairly obvious and intuitive as seen here. As you can also see, there are only 4 arrow keys, but 8 jog movements. In order to yaw or change the depth, the Shift key is used. The arrow key mapping for yaw and depth are presented on the next page. To yaw the vehicle or change its depth, press and hold the Shift key down, and then press the corresponding arrow key for the desired motion. As a third method of jog control, the jog functions have been mapped to the D-pad on the Xbox Elite hand controller. Like the keyboard, there are only 4 inputs on the D-pad, and a shift function is required to enable all 8 jog motions. The basic horizontal jog controls are shown here. The shift function for yaw and depth jogs requires that you press and hold the step shift button, shown here, and then press the corresponding D-pad quadrant for the desired motion. So to summarise, dynamic positioning and the jog controls provide an effective and seamless means of navigating the vehicle autonomously, while still being able to take control manually at any time. Some benefits of dynamic positioning and the jog controls are: dynamic positioning enables station keeping and several autonomous modes including jog controls for precise controlled movements. Dynamic positioning is independent from auto modes, but both are usually used in conjunction with each other. Jog controls can be used from the on-screen buttons, the keyboard, and the Xbox Elite hand controller. Dynamic positioning simplifies the operator's workload and reduces the need for high-level piloting skills, even in challenging environments.
Thank you for watching. For a more interactive training session and a printable version of these lessons, please click the link in the description below to be directed to our video training library at download.videoray.com/training/VTL.